Drones and electric vertical takeoff and landing, or eVTOL aircraft, aim to be common modes of transportation and delivery.
Electric vertical takeoff and landing aircraft have the potential to completely change how we live and work.
Small drones can deliver packages that can have life-changing effects, like medical supplies and medicine.
Today, we essentially have flying laptops. The possibilities of what they can do are limitless.
With drones, Drone Up has changed the way Walmart is able to deliver its packages in a fraction of the time of traditional methods.
It's access. We are going to democratize speed, and that's where drones come into play.
I'm Dawn Zoldi, a former military attorney. Even then, I knew that drones were going to change the world, and today we see this coming to fruition. It's so incredible to be a part of history in the making. It's time to go behind the wings. Think about hailing an Uber or a Lyft. Well, instead of getting into that car, you're going to hop in one of these. And instead of possibly sitting an hour in traffic, you're going to get there in 10 minutes. We're here at Archer's headquarters in Palo Alto, California for two big things today. First, the flight test of the Maker. In fact, it's the first transitional flight we're going to see. We're also going to get a sneak peek at Archer's Midnight aircraft. That's their commercial model. And the vision here is for it to be a ride share. It's going to change the face of transportation. We're here inside the lab, and behind me is the Maker.
We're going to see this aircraft fly later today. It's a demonstrator, and they're doing flight testing.
So what they're going to show today for the first time is transitional flight.
That means taking off vertically in a hover to forward flight, where the wings are providing most of the lift.
So to understand better how this thing flies, we're going to hear from the Chief Operations Officer here at Archer, Tom Muniz.
So I was a young engineer doing airplane design work and had the opportunity to start working on new, exciting electric airplanes. And back 10, 12 years ago, that was like a crazy idea. Electric airplanes, like what does that even mean, right? But batteries are continuing to get better, motors are continuing to get more lightweight, and so actually you could make a new type of airplane to do some really cool stuff, putting all the technology together. So that's kind of what you see behind us here today.
What's different about it than designing just a conventional aircraft?
One of the unique things about the aircraft that we're developing here at Archer is that it's not just electric, but it also takes off and lands vertically. So it doesn't need a runway, it takes off like a helicopter. But unlike a helicopter, it doesn't have one big rotor system. It actually has many small propellers all around the aircraft. And the way you can do that is by having electric motors, which you can scale down, and then you have this inherent redundancy in the system, meaning any of the motors can fail and the aircraft still flies safely. That's only enabled by electrification. Super cool.
I imagine the lower cost for things like maintenance could also translate into savings for consumers. Like if someone wants to fly on this aircraft, like how does that translate?
We envision these airplanes flying in networks where they're kind of hopping one flight to the next, doing lots of trips per day. And what that translates into is really low operating costs, and that translates into low ticket prices. In the future, you'll be able to get out the Archer app, and you'll be able to say, hey, I'd like to go to this destination, and then that'll reserve a seat on a flight like this. Then you'll be able to go to the vertiport, and then you'll take your Archer to wherever you want to go.
So think about hopping on a plane virtually from anywhere, whether it's from a dock, a rooftop, or a parking lot. And once you start cruising, they rotate down and fly like propellers on an airplane. Here we are at the tail of the aircraft. Now, on a normal airplane, this is where the exhaust would normally come out. Noticed? There is none. So what's so special about electric? A couple of things.
Quieter, safer, more sustainable and accessible.
Those are all bonuses. On the downside, batteries can have limited lifespans and can be heavy. We are at the airport right now and we're getting ready for the flight test demo. It's gonna be awesome. So we made it to the Salinas airport. This is an active airfield and we're getting ready for the flight test of the Maker. It is an uncrewed aircraft that's about 80% of the production model that Archer is putting out for urban air mobility. They've gone through a small drone demonstrator to the larger Maker 80% demonstrator to what we're going to see later, their big production model for urban air mobility. So the future is here.
November Oscar Bravo Whiskey.
We've been cleared for takeoff, and what we're seeing now is the plane is lifting vertically. It's going to hover. Pretty cool. As it starts, the rotors are facing down, right? And so when it gets up there in that hover, they start tilting forward, and that's where you see the transition to forward movement. This vehicle is uncrewed, right? So there's nobody on board, there's no pilot up there, but you've got about 6 folks in a trailer making sure that everything's on track. This is a real live flight test. So they're proving their concept here, and they're well on the road to FAA certification. Really exciting times to see this in action here with the Maker. We've seen the demonstration model called Maker. In fact, we've seen it fly. And now this is the production model called Midnight. This is the one that's going to fly you around New York City. There are some similarities to the demonstration aircraft. Just like the Maker, this also has 6 rotors that tilt. So that's what's going to create the vertical lift. And this one's bigger. The Maker is a literally 80% solution. This is the full scale model that can fit 4 passengers and a pilot. The vision is urban air mobility, or UAM. And this is flying people around cities, short distances.
So nice to meet you.
You're well on the path to certification with the FAA. In fact, today's flight demonstration with the Maker, can you explain the significance of that?
The industry has largely been focused on research and development. While the technology is really cool and we could build really fast, high-flying planes, we want people to be able to use them and use them on an everyday basis. We recently showed a flight test of our demonstrator aircraft Maker, and that showed the capabilities of what these vehicles can do. It shows you how fast they can fly, but importantly, it shows you how quiet they really are. That was a big step in helping the public see that these vehicles are coming to market really soon. We've recently partnered with United Airlines. They've been a great partner to Archer, where they're buying aircraft from us and helping us stand up this entire industry. Electric vertical takeoff and landing aircraft have the potential to completely change how we live and work. So if you can imagine, not just driving to work every day, but potentially flying to work every day. Not just going long distances to take vacations, but flying somewhere locally and doing it on a more regular basis. That's the world that I want to live in.
That's the world I want to live in too. And thank you so much for helping create it. As one example of many that we're seeing now, that was so amazing learning about these aircraft and also getting to see one fly. You know, the FAA always talks about a crawl, walk, run approach. Well, guess what, everybody? We're flying. Small drones can have big impacts. While electric vertical takeoff and landing aircraft can carry people, small drones can carry packages that can be life-changing, like medicines and medical supplies. About 60 million Americans, or 1 in 5, live in rural areas, and drones can be the difference between hours to minutes to get those folks the urgent medical equipment that they need. The Choctaw Nation's reservation in Oklahoma occupies about 11,000 square miles. They are doing medical deliveries that are going to change the world. So James, what's at stake in terms of medical drone deliveries?
Well, in terms of medical drone delivery, we're looking at solving that disparity that we have between urban and rural communities. There's a lot of things that have happened with technology that have equalized the quality of life and quality of health between urban and rural areas. But transportation is the last part. And that transportation challenge, being a long way from medical clinics, medical services, being a long way away from emergency response personnel, those things impact health outcome. Unfortunately, in the 21st century in the United States of America, we still have health outcomes that are determined a lot by your zip code. Drones, we believe, are going to help equalize that. We represent what most rural communities look like. Our reservation looks like other Native American reservations. We look like other rural communities.
Tell us a little bit about the medicines or the equipment that drones can bring to people in a quicker manner that can save lives.
We looked at a simple case of access to EpiPens and potential for saving lives. There are dozens and dozens of people every year that die because they don't have access. Well, that's a very small, simple item, but getting it to somewhere quickly is the challenge in rural areas. A lot of things that in the right situation you need immediately. You can't wait 45 minutes or an hour. Drones are perfect for that.
So James, we're going to see a demo of a medical drone delivery, but this package you're holding is something that could be used in a real-world scenario. So tell us a little bit about this.
Yeah, it's surprising, in emergency situations, a lot of times it doesn't have to be very big packages or very much equipment. And it's amazing what we can pack into these small packages like this.
So let's see what we got here.
We've got quite a bit. There's multiple situations that we can deal with this type of a kit. But you could imagine something like this could also be packed with insulin, we could have it packed with EpiPens, we could have it anti-venom, all sorts of things to face situations that we might see in a rural area like this.
So what you're going to see is this drone that's going to have a 5-pound package loaded on it. It's going to have bottles in there that are filled with liquid, which basically simulate either medicines or critical medical samples that need to get from one location to another. We're going to see it take off, and then we're also going to see it land. This test flight illustrates one of the hardest use cases where there are liquids on board, about 5 pounds. The conditions are windy. So the key here is to show the stability and reliability of the drone so it can fly and get these medicines to where they need to go safely. This is one of those examples where you're basically going to simulate the hardest use case.
We're going to try to do the worst case scenario. And that's what the FAA likes to see as well, because whenever they're testing, they say, okay, what's the worst case of this situation, and how are you going to demonstrate you can do that safely?
Well, you did some of these flights, so could you give us a real-world kind of example of if this was driven by car, how long this would have taken versus how long it actually took you to do the same delivery with a drone?
Even if you're only flying at 30, 35 miles an hour, if you look at putting a car on the ground from the initial point to the destination, and then compared that with the drone flight, and we cut the time almost in half.
That's significant, especially if we're talking about life and death situations. As part of the Federal Aviation Administration, or FAA's Beyond program, companies can come to the Choctaw Ranch and safely test out the most difficult use cases, whether drone delivery, beyond visual line of sight flight, to make sure that they're doing this in a place where the air and ground risk is minimal and to inform decision making. While the testing and experiments occurring here in the Choctaw Nation for drones and medical delivery are unique, the impacts they're going to have will be universal. In Baltimore, Maryland, Mission Go is pushing the envelope even further for medical drone deliveries. In 2019, they delivered the first organ by drone successfully to a transplant recipient.
We see drones as a tool of the future. Medical transport is critical. Time is always of the essence. Nobody wants to be waiting around for blood. Nobody wants to be waiting around for their organ that they need. Now, I'm not a doctor, I'm a pilot, but what our doctors do tell us is that for every minute an organ is outside of the body, it's degrading, it's dying. The organs don't want to be outside of the body, they want to be inside of the body. Our organ transport and procurement, transportation across the country, they do a really good job, but that's not to say that it can't be better. Uncrewed aircraft have a really unique role in making that whole process better and making the recipients on the other side, their quality of life better. In 2019, Dr. Joe Scalia with the University of Maryland Medical Center came to us with an absolutely wild idea of transporting a human organ on board an unmanned aircraft. What is the art of possible, but we were up for the task and the challenge, and we did just that.
The long game with these technologies is that we'll be able to limit the amount of time that expires between explant and implant. We'll also be able to reduce the cost of the shipment of organs. We'll have access to immediate transportation, certainly be more efficient, and I think there are a lot of upsides. In this initial series, just trying to organize the logistics, I think, is really critical to moving forward. So this is really about getting it right, working as a team, you know, a group of surgeons, engineers, drone folks. Yeah, it's a big group of people to bring together, but we've been able to do it, at least here today, so that's exciting.
It's cleared for launch. Let's make some history.
Launch. The night came of April 2019 where we flew the first human kidney for transplant over the city of Baltimore. Now, mind you, the task of doing that was monumental. It was not as easy as just somebody showed up with a kidney, we put it on the aircraft and pushed a button. There was more than 400 people involved to make that happen. It was a literal village to make this a success. And in the end, while it was a short flight, it was around 3 miles in length, the fact is that we did it, and it was successful.
Confirming Helmel's active, temperature's appropriate, organ doesn't appear to be injured at all. Looks like a perfectly transplantable organ.
And it proved that uncrewed aircraft could be used for more than just taking pictures or flying around for fun, but it could literally be used to save lives and transport a human organ in a safe manner to somebody who needs it, and they need it right now. It's an excellent tool that we can have in the box to supplement a huge endeavor that we're trying to create better quality of life for patients in the end.
With medical delivery by drone, small packages can have a massive impact. Since the COVID-19 pandemic, drone delivery has really taken off. Why? Because they're the ultimate social distancers.
In a small town in Arkansas, a revolution is taking place in the world of last mile delivery.
We all know the traditional way of shopping. You have to get in your car, drive to the store, pick up whatever it is you're looking to buy, and then head on home. But with drones, I can get any of this delivered right to my backyard, even a rotisserie chicken. As one example of many that we're seeing now across the country, Walmart has teamed up with DroneUp to bring a number of their products from the store to your door by drone, more conveniently and quickly.
Each one of these Walmarts becomes distribution centers with products that are custom fitted for the audience around them. Being able to deliver from the Walmarts to those residences within that range allows us to serve millions of customers every day.
Tom, how would you describe this moment in time in terms of the drone industry?
If you think about where we are in the evolution of the drone industry, specifically related to drone delivery, prior to the pandemic, there were no drone delivery operations going on in the United States. Today, in addition to what others in the industry are doing, we have 34 locations delivering to 4 million customers. That's happened in just a few years. And now with the FAA regulations evolving and the technology evolving and the communities realizing this is really happening, we had mayors of cities all over the country asking if we would come into their cities and do the very same thing. You're seeing partnerships like the one we have with Walmart. I can't even imagine what you're going to see over the next 2 to 3 years.
From those initial days when you were doing these tests with Walmart for COVID-19 test deliveries to today, your operation has evolved so much. How has it evolved?
It's evolved a lot. In those early days, there were no off-the-shelf drones designed for delivery. Today, we've got drones that are custom built and designed with all kinds of safety protocol, autonomous software, integrated with airspace management so that we can deconflict and maintain safe airspace. Today looks nothing like it looked even 2 years ago.
What is your vision of the future for drones?
My vision of the future is that we're going to be, within 10 years, we're going to be delivering about 5 billion packages a year. If you think about that, that's probably 25% of the total delivery market. And that's from a technology that was not even being used just a few years ago. When we talk about the last mile, we recognize drones aren't the final solution to the last mile. Over the next 10 years, you're going to see the last mile revolutionized. And we believe that it's going to be autonomous aerial, autonomous ground, and electric vehicles. We know the part that we play in it, and we know that we're going to change the last mile over the next 10 years.
DroneUp continues pushing the boundaries of drone delivery. Its partnership with Walmart is going to change the way we all receive packages.
It was so great to meet you. Pratibha, what kind of impact do you think drone delivery can have on everyday people?
Our customers have told us that Convenience and saving money is really important to them. They want to have express delivery for things that they need in a pinch, and that's where drones come into play. It's access. We are going to democratize speed. If somebody lives in rural America and wants access to prescription drugs and regulations allow us to deliver prescription drugs, we are able to do that. And the third one is sustainability. So drones mainly operate through electricity, and it prioritizes planet and making sure we are being sustainable in how we use our resources.
How do drones fit into your last mile delivery strategy?
We've talked about Walmart's footprint, 4,700 stores within 10 miles of 90% of the US population. So 120,000 SKUs or items are available for express delivery for our customers. The maximum weight that we can deliver right now is 10 pounds, but we're working with FAA, local state regulators, to expand that. It's not about the technology itself, but what problems the technology is going to solve.
So in your experience, what are the top items that people are ordering for drone delivery right now?
The top items are cookies and cream ice cream, paper towel, lemons, and then rotisserie chicken. Isn't it fun that we are delivering rotisserie chicken to people's backyard?
I personally can't wait to get my rotisserie chicken delivered to my backyard. I mean, think about it. With drone delivery, chickens really can fly.
This sounds like it's going to be in the future, but it's happening now in Bentonville and coming to a town near you.
Now that you both have explained how Walmart drone delivery works, I'm so excited to experience it for myself.
I'm getting s'mores drone style. I'm here with Ken. He is the hub manager here at Bentonville, Arkansas, Store 100 for Walmart. And you're going to show me how to place a delivery.
Absolutely. It's easy as any web order you've ever made.
All right, let's do it.
All right. All you got to do is click in your address.
All right, here we go. Okay, super easy. I put in my address, and now here's all the different things that I could order, but I want to order stuff to make s'mores. So what do I do?
You just scroll to the items you want. So in this case, you want s'mores, so you just click on the item to add to your cart.
And it looks like we're good to go. So then I go to my little cart.
Yeah. And then once you hit submit, the order process begins.
Ken, that was so easy. That took me less than 2 minutes.
Yeah, nothing's different than any other order, except how it gets to you.
So I placed the order, Walmart got the goods, and now what happens next?
Now we just load it up in the box and get it ready.
Okay, very
good. You want to load it?
Sure. All right, in go the grams, in go the chocolates, and the mallows.
All right, all that nice and center in our box, and close it up. And that's it. Let's get it flying.
Package is loaded. What's next?
Ready for takeoff.
So Ken, we're up on the roof here of the hub, but what is this behind us?
That's our remote pilot in command. He's the one that manages the flight. The aircraft is completely automated, but he still supervises all operations.
Safety is job number one.
Of course.
Good, because I sure hope that my s'mores arrive safely. There go my s'mores. In the air, we see the drone flying with precision and reliability to its ultimate destination. On the ground, we got to witness firsthand the delivery by drone of goods right to the customer's doorstep. So here we are at the landing site, so tell us what we're going to see.
It's going to travel for us here at this hub. We fly at 115 feet. It'll fly in and it'll descend down to 80 feet, which is our safe delivery altitude, and then it will rappel down on a line your box.
I think I see it coming right now.
Yep, there it is. It is, because there it is.
And the package is descending. Wow, that comes down pretty fast.
Puck captured.
All right, here it is, the big reveal. And there they are, fully intact. So when you're at home and you don't want to go out, but you have a hankering for a s'more, drones, we're gonna make that happen for you. So I got to experience this myself today. Absolutely unbelievable. From order to delivery, less than 30 minutes. I can't wait until this comes to Colorado Springs.
We look forward to visiting.
From flying taxis to drone deliveries of groceries and even human organs, we've seen how drones and eVTOLs are transforming everyday life.
There's a real opportunity here to be able to move a lot of people into the air and allow them to not only just save time, but actually figure out what they want to do with that time.
Today, people are using drone delivery as a convenience. In the future, it will become something that people simply can't live without.
Not only will we see our health benefit from it, but we'll see this convenience that will make our lives much more enjoyable.
Flying is really not new. We've been doing it for a long time now. Artificial intelligence, sensors are all getting integrated today to make these flying laptops even smarter and more efficient than they ever have been.
These technologies increase access, increase speed and efficiency in ways we've never seen before. They're on the way to becoming a huge part of our daily lives. As this technology continues to mature, keep an eye in the sky for a drone near you.
The James Webb Space Telescope is the largest and most powerful telescope in space, uncovering secrets of how galaxies were formed and how the universe was created.
The James Webb Space Telescope is unraveling the mysteries of the universe.
We'll meet the scientists, engineers, and visionaries who brought this telescope to life.
The early days, just a few people, whiteboard, how do we build something that could actually work?
We're on a mission to unlock secrets from the deepest, darkest parts of the universe.
We can actually see light that was emitted more than 13 billion years ago. We're literally traveling in time.
It took so much ingenuity, collaboration, and dedication to design and develop this telescope. I can't wait to see what we discover.
Being a part of something bigger than yourself, that is really why I did this.
It's time to go behind the wings. This is going to be cool. I'm Myrna James. I'm a science journalist specializing in all things technology. Here at Wings Over the Rockies Air and Space Museum, we transport the magic of space to you right here on Earth. Today we're traveling through space and time alongside the James Webb Space Telescope, which is the most capable telescope in the cosmos. Using infrared technology and a revolutionary segmented mirror, Webb can gather 6 times more light than the Hubble Space Telescope. The Webb is uncovering how the universe was created and is answering questions so profound we didn't even know we had them. With the ability to observe galaxies more than 13 billion light years from Earth, get ready to travel through time. Webb launched in 2021, but the idea was sparked more than 20 years ago at NASA's Goddard Space Flight Center.
It's human nature somehow to be fascinated by space in our place in the universe. So I was taken by that just like anyone. When I started on the Webb in 1997, there were just a few of us. It was just an idea, but in front of us was to figure out how do we build something that could actually work. The Webb mission was conceived in the late 1980s, early 1990s to connect the dots between the achievement of NASA's COBE satellite, which showed us the oldest light in the universe. Around the same time, the Hubble Space Telescope was launched.
1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
And it took its deepest image of the cosmos that it was capable of doing at that time. And that deep field image, it looked back in time to a point when the universe was about 1 billion years old. The epoch that COBE saw, the universe was a few 100,000 years old. And so between those two epochs is a mysterious, poorly studied epoch that was referred to then as the cosmic dark zone. And it's of great scientific interest because that is the point in the evolution of the universe when the first stars and galaxies formed. The answers to all our questions are in starlight, and we have to be clever enough to extract that information.
In order to create a telescope that can see further back in time, NASA needed to invent new technology that could gather light from some of the first stars and galaxies in the universe. But first, they had to overcome the challenges that plagued the earlier space telescopes. Hubble, for instance, required hands-on human repairs.
A lot of people today don't even remember, but when the Hubble Space Telescope was launched, the primary mirror actually wasn't quite the right shape and could not focus light properly.
A significant spherical aberration appears to be present in the optics.
There was actually multiple repair missions and upgrade missions for Hubble. The very first one was really to fix the blurry vision, and then from then on in we were really upgrading the instruments. John Grunsfeld was an astronaut who helped to upgrade the instruments.
The Hubble Space Telescope was launched in 1990. In 1992, I became an astronaut. At the edge of the telescope, which is 2.4 meters across, the shape of the mirror was wrong by about 1/40th of the width of a human hair. But that was enough to make the images slightly fuzzy. So for an astronomer, that was bad. So instead of being, a great observatory and all this anticipation, it was a sort of good observatory, or maybe a little less. As an astronomer, going to the Hubble Space Telescope is kind of the holy grail of an astronaut's mission. I had the, unbelievable fortune of being able to go up 3 times to the Hubble and do all kinds of repairs and upgrades to the telescope, such that now Hubble's coming up on its 33rd birthday on orbit, and everything's working, and we're still doing incredible science.
So you were actually able to get inside the telescope here?
Yep. Now clearly this is just a model. The real telescope is 5 times bigger, about the size of a tour bus. And what you can see is that the telescope has handrails that we could use to climb around the telescope, but more importantly, it was designed to be modular, to be fixed, not only to put in new electronics, but to put in new scientific instruments. And so we were able to open these doors on orbit. I was able to climb inside the telescope to take out the old scientific instruments and put new ones in. And so you can see this opening was big enough even for my spacewalking partner, Steve Smith, who's about 6'2", in his spacesuit to fit inside.
So you did 8 spacewalks. Does it ever get old?
I wondered during training whether I would ever get tired of getting into the spacesuit and going into the big pool we call the neutral buoyancy laboratory. I've spent hundreds and hundreds of dives in the spacesuit practicing, and even that's not old. 8 spacewalks, everyone is just spectacular and magical. I was on the end of the robotic arm, moving back towards the Hubble Space Telescope, when all of a sudden I thought, is this real? I just can't believe that I'm here out in a vacuum in my spacesuit with the Hubble Space Telescope orbiting the Earth, going 17,500 miles an hour. It was kind of silly, but I just reached out with my index finger, and touched the Hubble to make sure it was real. And then, of course, it was, all work from then on.
So the ability to upgrade the Hubble on orbit is one reason that it's still so productive and still up there after 33 years. And that's not true about the Webb telescope. It's actually about 1 million miles out.
The James Webb Space Telescope is an infrared observatory. That's light from heat. And so we have to put the James Webb Space Telescope really far away from the Earth so that it wouldn't see the Earth's warmth. But that has a downside. It's too far away. It's 1 million miles from Earth. So the James Webb Space Telescope is high stakes that we can't go fix it. And so a lot of effort was put into making sure that it would work the first time. It's going to be amazing what we find out. But I think the biggest discovery from the James Webb Space Telescope is probably going to be the answer to a question we haven't thought of, something we truly discover that we never knew about.
What did it take to build the most powerful space telescope? With any project as ambitious as the Webb telescope, it takes thousands of people and many, many years.
For some of them, their entire career was riding on its success, and it actually went perfectly. Webb was primarily built, engineered, and designed at Northrop Grumman Space Park. The components were manufactured in laboratories across the globe, then were sent back to the Space Park campus for assembly.
The telescope itself and all the components came from different places across the U.S. and across the globe. And over behind me, that's where we did all of the engineering work to come up with the design, to come up with the ideas of how we were going to put it together, etc.
So Charlie, why are telescopes so important?
What made Galileo think he needed to make a telescope is to go see the things that we can't see with our naked eye. So we call it a telescope, but it's so much more than that. There are unbelievable quantities of materials that went into that telescope. from all around the world. Exotic materials that are really lightweight, some that are very hard, very stiff, all kinds of different materials that engineers used to put together the telescope. And it took millions of hours to design it, build it, test it, and get it ready for launch. I spent about 20 plus years as an engineer working on the telescope. Now it's time for the scientists to use it for 20 plus years, to make new discoveries, to find out things we don't know yet.
Normally in a project, if you count up the number of miracles that have to occur, if you get above 1, you're in big trouble. On the Webb, we had 10 technologies that we had to invent just to make our concept doable. We realized that we had 2 enormous problems that almost stopped the project dead in its tracks. This big mirror was bigger in diameter than the biggest rocket. That was problem number 1.
This mirror was so big, it couldn't even be launched in a rocket. It has to unfold and deploy in space.
That's right. So Webb's mirrors are huge. They're 6.5 meters. And so the fairing that we can launch from are about 5 meters. So they're, just a little over 1 meter too big. So what we had to do is fold back 2 sections, one side on the left side, one side on the right side of the mirror, so that they can fit into the launch vehicle, kind of standing straight up and down.
Problem number 2 is that to build an infrared telescope, the telescope has to be very, very cold, because everything above absolute zero emits infrared light. If we didn't make the JWST cold, it would be blinded by its own infrared emission. How cold do we have to make it? Really, really cold, almost minus 400 Fahrenheit. The JW Sunshield has an SPF of more than 1 million. If you had it on the beach, you would be very well protected, and it enables the Webb to achieve this low temperature.
Most telescopes have a sun shield of sorts. What you're probably more familiar with are barrels around a telescope. That eliminates light from entering the telescopes that's not exactly on axis. That's what the sun shield on Webb was trying to do. And so the way that it works was, if this light over there is the sun, and I want to look at the dark of space, the sun shield was always shielding the light from the telescope, so my eyes in this case, so that I never see the sun and I can look the other direction into the darkness to look at the first stars and galaxies.
From its sun shield, which is the size of a tennis court, to the primary mirror, which is 21 feet in diameter, the Webb telescope is an engineering marvel.
Engineering is an empirical science. You have to build prototypes, test them, see what went wrong, build more prototypes, and so forth. And on the Webb, we were able to do all of that. One of the things that makes our work difficult is that we have to work in these very, very clean environments, wearing special garments. And this is one of those clean rooms. This is really one of the largest rooms like this in the world. You can see the people are wearing these white suits, called bunny suits, and that's because the dirtiest thing in these rooms is the people. The number of people that can be in the room at any one time is limited. It's cleaner than a medical operating room. This whole brown wall is a giant HEPA filter. So the air is constantly flowing horizontally in this room through that filter. The goal is to remove every single particle in the air that can get into the hardware.
The James Webb Space Telescope is not like the Hubble, which could be repaired in orbit, because it's 1 million miles out. When the scientists launched Webb, they had one shot to get it right. So they implemented, of course, extensive testing before it ever left the ground.
The testing is as important as the flight, and so it becomes a constraint on the design. Every element of design we have to include how will we test that? What hardware do we need to test it? We call it ground support equipment, or GSE. So this is one of the payload areas at Goddard where we're testing spaceflight hardware. And much of the testing we do is done in space simulation chambers that simulate the vacuum and temperature of space. And so these large objects are space simulation chambers where spaceflight hardware is being tested, as we speak. These are giant vacuum chambers that simulate the vacuum and temperature and overall environmental conditions of space. The Webb science instruments were tested here for many, many months to ensure that they would work properly in the Webb mission. And so to do testing, we have to simulate the environment as best we can here on the Earth. In addition to making sure that the hardware will work in space, we have to make sure that it can survive the rocket flight into space. So we typically have to simulate that as well. And these big steel doors are labs that contain giant vibration tables where we will put the payload on the vibration table and shake it to simulate the rocket flight to space. And we were able to do all of the testing that we needed to do to be confident that this enormously complex thing would actually work.
Once it was built, the big question was, can it successfully be launched?
Being in the Mission Control Center with 100 other people that had also poured their hearts and souls into this telescope, the launch was nerve-wracking, to say the least. There still were some risks. You know, we had a lot of single-point failures to overcome. It was also very celebratory because we did have a lot of confidence in our partners at Arianespace to get us up into orbit safely.
From Jean-Luc Voyer, all systems are go. We're inside a minute now, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way. And we have engine start. And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
Back in the Mission Ops Center in Baltimore, we were kind of like, okay, get to work. It's now our time. So we still had 6 more months of deployments and commissioning to get this thing to do what it's now doing and exceed expectations. The successful launch, that was just the beginning. And now we've turned it over to the science teams to find out what they can with our data.
There's no one better to talk to about what goes on with this telescope than Kenny McKenzie.
I had an 8th grade social studies teacher. Her name was Krista McAuliffe. She perished in the Challenger disaster and kind of motivated me to enter the space business. I entered in 1984. I've spent a lot of time with a lot of different missions, but beyond all that, this is the most exciting one so far. Basically, we're on the campus of Johns Hopkins University. This is the Muller Building. It's the home of the James Webb Science and Data Processing Center and now Mission Control for James Webb. During the commissioning and instrument activation phase, both of these 2 rooms are completely full with probably 100 engineers at any one time.
So in this room is where the deployment of the mirrors was commanded, really.
We conducted all of the deployment activities from solar array deployment, which was the primary and most crucial deployment that we had to do for us to have power. So the solar array has to come out. If you don't have a solar array, your mission is basically done. So that was a very exciting, very positive start to our mission.
What was the mood in the room at that time?
It was very, very nervous, of course, as you would fully expect. People were on their feet. Everybody had a job, and we all worked very well together, and we were able to deploy it perfectly.
And we have a fully deployed JWST observatory.
Yes.
After 30 days, we were elated. I mean, we were tired, but we were elated. We had another 5.5 months to go with all the instrument commissioning activities, but we felt comfortable that all the subsystems were working, the communications were good, beyond all reasonable expectations, worked as, as designed.
That's incredible.
It was very incredible.
It's really just the beginning of a whole new era.
We're still a baby. We've been up on orbit for just over 12 months. We continue to explore and develop and uncover amazing items. It's a good time to be part of the Webb program.
Okay, this is the real-time screen of what's happening.
Yeah, depicted on this screen basically is the view of the observatory as it sits in space. We use the Deep Space Network, which is 3 different complexes located geographically around the world. It gives you a visualization of where this observatory and the telescope are pointing.
So scientists from all over the world are so excited about this data. How do they use it?
For each program, it looks at a different part of the sky, and the longer you stare, the more light that you're actually going to receive. Some of these observations may be, in the order of 2 or 3 hours, and some are up to 20, 25, 30 hours.
So where are we in the process of getting this data?
We're at the tip of the iceberg. We were very successful in conserving fuel, so we anticipate having a 20-year fuel budget, which will allow us to do imaging and so forth as long as the instruments are able to allow us to take data.
Over here is actually one of the main places that we align the telescope from. And up here you can see we call it the commissioning flow. These are all the steps that we did to align the telescope over about a 3-month period. As we went through the entire process, we X'd them all out. And there's one particular step in the middle there where we got the very first images that were focused, and that's why it says champagne, because after all those years, that was the moment we knew we built the right telescope.
Wow.
So we were
the moment to celebrate.
The moment to celebrate. When you look at it from the 20,000-foot level, things went amazingly well. Probably better than any of us expected. And the thing that was really special is that when we got to the final performance, it's almost performing twice as well as we expected.
So why is this so important to you, Lee?
These kinds of missions, these missions that bring back amazing images and help us understand how we got here, they inspire young people. And I think that's what it's all about. It shows what human beings are capable of doing when we work together. And maybe that's a lesson that we can apply to other challenges that we have here on Earth.
It's so inspiring for science in general.
We could be learning new physics that then relates to what's happening here on the Earth. We still have a lot of the universe that we don't understand, from dark energy to dark matter, and the Webb telescope will contribute to that as well. It's been a little over a year, and of course, we've come really far in terms of how well it's performing, getting it operating. But from a science perspective, we're really just getting going. From now on, every field is a deep field, and that's sort of the way it's been. This is going to be a very exciting few years, maybe some of the most exciting few years in the history of understanding our universe.
The telescope is built, deployed, and the science is rolling in. The data is epic. So you were the principal investigator for that first batch of images. How were those images received by the public?
It was a very interesting process. It took us years to prepare for this. And of course, we had this task of demonstrating to the world that this $10 billion observatory was worth it. Right? That we could produce something that anybody would look at and say, wow, this gotta be making amazing science. And that included producing these beautiful color images. And so, of course, we were worried about that. We were nervous. I mean, can we actually do that? We didn't know what the images would look like. Like, this is such a new observatory with such new capabilities that we could try and predict what we would see, but we couldn't really predict it. And all the data that the observatory takes really is the property of the world. And so eventually it all becomes public, and anybody can download the data. You don't even have to be a scientist to download the images and look at them.
So Klaus, you saw the first images as they were coming down from this telescope.
Right, I saw the first color images, the first science images that we took, the ones you've seen. For example, the cosmic cliffs or the first deep field. The primary feeling I had was really of loneliness, because the first image came down, it was sort of late at night. I didn't download it here in the office, I actually downloaded it in my basement at home. So I was sitting there this evening in my basement all alone, and I was looking at this image of the deepest view of the universe that anybody had seen. And it was profound loneliness because I couldn't share it with anybody.
So the colors are gorgeous. And what do they mean?
So the colors mean something physically. So when we pick a filter, what that does is it actually picks out a signature of a specific molecule or a specific element. So here I have pulled up an image that uses a filter that sees organic molecules. So 4.6 billion years ago, our solar system looked like that. All this stuff around you see here, that's the organic material that we're made of that ends up on the planets in there.
It makes me feel like I'm part of the universe.
Oh, we're very much part of the universe. Right, as Carl Sagan said, we're the universe's way of thinking about itself.
So we're starting to get this data now. Is it creating more questions than answers?
Oh yes, it's creating more questions and answers, absolutely. And I think that's where we want to be, right? If we are starting to run out of questions, we're not doing something right. That's not how science works. We want to answer questions, but we want to make more questions than we have answers. There'll be future telescopes because we need that to answer all those new questions we have.
You and so many people have dedicated their careers to this project. How does it feel now that it's up and it's running so well?
It's performing better than expected across the board. And that is true in terms of its lifetime expectancy. Its optical performance is about a factor of 2 better than the expected performance. How stable it is when it looks at an image is about a factor of 7 better than expectations. So yeah, it's incredible to see how well it's performing up there.
One of the great things about science is that we learn new things. And often those new things that we learn overturn a previous idea. That's certainly going to be the case with the James Webb Space Telescope. It sees the universe so much more clearly, so much deeper. I think there's some big surprises in store that James Webb will give us.
The Webb is giving humanity its very first high-definition view of the infrared universe, and the view is fantastic.
The great thing that I took away from Webb and being part of this project is helping to build something that fundamentally contributes to humanity's knowledge.
My dream is to continue trying to do hard things. I love the idea that I've gotten to work with a team that has enabled the science classes that my kids will take aren't going to be the same science classes I took. That's very exciting.
Building the first segmented space telescope, this is sort of like landing on the moon for telescopes in a sense that it's the first of a kind. But a segmented telescope is scalable. We can build bigger and bigger. And then after that, we can think about assembling telescopes that are made up of segments like this. And that's what we're going to need someday if we want to take an image of a planet just like Earth around another star in high definition. The Webb telescope is the first step on that journey.
With its successful launch and deployment, Webb is expected to support scientific observation for about 20 years, unveiling the secrets of the universe, one discovery at a time. All of us at Wings Over the Rockies Air and Space Museum look forward to uncovering more mysteries beyond our planet and sharing them with you. We'll see you next time on Behind the Wings.